Hello and welcome to the Unit 7 Section 1 video on polygons. So in this unit we are going to move forward into shapes that have more than three sides. We spent the last 3 units talking about triangles and now we're finally going to go beyond that. So let's first off talk about how we identify polygons. A polygon can be identified by the number of sides it has, and these sides have to be straight, okay? That's what differentiates a polygon from something like a circle. You have to have multiple sides and they have to be straight sides. So a polygon, by definition, is a closed flat figure made of straight segments that do not cross each other. Each segment that forms a polygon is a side of the polygon. The common endpoint of two sides is a vertex of the polygon, and a segment that connects any two non-consecutive vertices is a diagonal. So here in the figure you can see a side here, and each of these sides are red here, okay? So everything that is a side is in red. Then you have a vertex. You have a vertex at C, you have it at B, you have it at A, E, and D. It's basically where two sides meet. And then a diagonal is a line that goes between two of the vertices, okay? So here's an example of a diagonal B to D. If we could draw more diagonals, we could have one that goes from E to C, we could have one that goes A to D, we could have one that goes A to C, and so on. So B to D is not the only diagonal, it's just an example of one. So we can name a polygon by the number of its sides, and that's one of the things that I pointed out initially here. So let's talk about what name we have for different polygons. So the first one, fairly obvious. You have a triangle if it has 3 sides. We've spent the last 3 units talking about that. Now, what about 4 sides? Well, we know squares have 4 sides, but rectangles also have 4 sides. So do parallelograms and trapezoids and kites and rhombuses. So since there are different types of 4-sided figures, there is one general term that we use to collect all of those together, and that term is quadrilateral. A quadrilateral is a polygon with 4 sides. That's the generic term for it. All right, if we have 5 sides, it's called a pentagon. If it has 6 sides, it's called a hexagon. We'll come back to 7 sides. 8 sides is fairly obvious as well. That's an octagon, like a stop sign. And let me misspell it right. There we go. So let's come back to 7 sides. The rest of these are not quite as obvious. So a 7-sided figure is called a heptagon. A 9-sided figure is called a nonagon. A 10-sided figure is called a decagon. Now we do not have a name for an 11-sided figure, so that'll get lumped to the next one, but we do have a name for a 12-sided figure, and that is a dodecagon. So same term that you use for a 10-sided figure, just put DO in front of it. Now what if it has n sides? So what if it has 11 sides, or 13, or 14, or 15, or so on? We call these n-gons. So what you would call a 11-sided figure is an 11-gon, or a 15-sided figure is a 15-gon. A 78-sided figure is a 78-gon, okay? So let's use this information to do example 1. We want to tell whether each figure is a polygon, and if it is a polygon, we're going to name it by the number of its sides. So this first figure has nothing that crosses, so it is just a 1, 2, 3, 4, 5-sided figure. So it is a polygon, and more specifically, it is a pentagon. For B, this has sides that cross each other, and you cannot have sides that cross, so this is not a polygon. All right, C, nothing crosses, everything is straight edge, so we can count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8. So this is a polygon, and it is an octagon. It doesn't look like your traditional octagon, but it does have 8 sides. And then finally, D, we have a curved side. If we have a curved side, then that alone makes it not a polygon. All right. let's move on to classifying polygons. All the sides are congruent in an equilateral polygon. Just kind of like you had an equilateral triangle, all three sides were congruent. If all the sides of a polygon are congruent, you have an equilateral polygon. All the angles are congruent in an equiangular polygon, just like we had with an equiangular triangle. A regular polygon is one that is both equilateral and equiangular. All the angles are the same, all the sides are the same. If a polygon is not regular, it is called irregular. A polygon is concave if any part of a diagonal contains points in the exterior of the polygon. So, for example, here we have a diagonal going from this vertex to this vertex and is outside of the polygon. So that makes it concave. If no diagonal contains points in the exterior of the polygon, then it's convex. So here's an example of a convex quadrilateral. We have drawn all the diagonals and they are all on the inside, so therefore it is convex. So a regular polygon is always convex. So let's take that information and do example 2. We want to tell whether each polygon is regular or irregular and tell whether it is concave or convex. So starting with A, we have a rectangle, but it is not regular because not all the sides are the same. The angles are all the same, but the sides are not all the same. So this one is irregular. If we were to draw a diagonal across the inside, here and here, they would both be inside, so it is convex. By the way, a regular quadrilateral is a square. All right, example B. All the sides are the same, but not all the angles are the same. So it's not regular, so it's irregular. And we can draw a diagonal from this vertex to this vertex, and it would lie on the outside, so it is concave. The way to think about it is this part of the polygon is caved in, so it's concave. You can think about it that way. In C, we have a pentagon. All the sides are the same, all the angles are the same, so it is regular. And remember, if it's regular, then it is automatically convex. If we drew all the diagonals from every vertex to every other vertex that you can form a diagonal, they would all be on the inside. And then finally for D, not all the sides are the same, and not all the angles are the same, so it is irregular, and it is also concave because you have one diagonal here that is on the outside. All right, so the remainder of this section involves constructing a regular hexagon given one side. So follow those directions for your construction, but this is the end of the lecture part of this section. In the next section, we are going to talk a little bit more about different types of polygons that you can have, and we're going to talk a little bit about the interior and exterior angles of polygons and what we can do with those.